Hello APC Mechanics students, today we'll solve the past paper of RQ 2001, exercise number 1. A motion sensor and a force sensor record the motion of a cart along a track. As shown above, the cart is given a push so that it moves toward the force sensor and then collides with it. The two sensors record the values shown in the following graphs. So in the first graph we have velocity versus time, so notice that this is velocity, which is a vector quantity. Similarly for the force. Now in part A, they're asking us to determine the cart's average acceleration between instant t1 and instant t2. We know that the average acceleration is given by delta v over delta t, and that would be v final minus v initial over t final minus t initial. Now the final instant is given by 0.37 and the initial instant is given by 0.33. V final and V initial refer to what? Now V initial refer to T initial and V final refer to T final. So the initial velocity is determined graphically by referring to the instant, which is given by 0.33. And if you look carefully at the graph, 0.33 is here. So if you go up, that would represent the initial value of the velocity, which is given by 0.22. So let me write minus 0.22, and for 0.37 that would be the final velocity, which is here. And if you look up graphically, because we're going from minus 0.10 to minus 0.20, that would be minus 0.18. And plugging that expression on the calculator, we're gonna have a value of minus 10 meter per second square. Then the average acceleration among this duration is given by minus 10 meter per second square. Now determine the magnitude of the change in the cart's momentum during collision. Now remember that the change in momentum, which is the impulse, can be determined via an integral, which is given by f dt. And what's the interpretation of this integral? Which is basically the area under an ft curve. So basically the change in momentum is determined by finding the area under the ft curve. And here we can split the following curve into several areas. So let me say that this is 1, that would be 2, that would be 3, and that would be 4. So which is given by a1 plus a2 plus a3 plus a4. Now the first area is given by triangle, which is half base times height. So the base is given by 0.01 and the height is 10. So half base 0.01 times 10 plus the area A2, which is 0.02 multiplied by 10, plus the another symmetrical area, which is given by half 0.01 multiplied by 10, plus the area of the triangle 4 of a base 0.02 and the height from 10 to 40, that would be 30. And plugging that expression on the calculator, we're gonna get a value given by 0.6. And the unit of change in momentum is given by kilogram meter per second. Now here, interesting enough, you're interested in the magnitude, so no problem if this is positive. So let me say then, delta P in this case is given by 0.6 kilogram meter per second. Now they're asking us to determine the mass of the cart. We know that the change in momentum is given by m delta v, and we're interested in determining m. So m would be given by delta p over delta v. But remember that this is the magnitude, which is positive. So let's consider the magnitude of the velocity of the change delta v. So I will put here the absolute value. Now delta p is given by 0.6, and the change in velocity during the same time interval, which is given from 0.33 to 0.37. is determined by the following, which is basically the absolute value of minus 0.18 minus 0.22, and that would be 0.6 over 0.4, which is basically equal to 1.5, and because everything in the SI, so what's the SI unit of the mass, is given by kg. Then the mass of the cart is given by 1.5 kg. Now in part D, they're telling us to determine the energy loss in the collision between the force sensor and the cart, and the energy loss in the collision would be the change in the kinetic energy, because initially the speed is given by 0.22 and the final speed is given by 0.18. We're talking about speed, not velocity. So the energy lost would be the change in kinetic energy, so delta K, which is K final minus K initial, and that would be equal to half mv square final minus half mv square initial. And now we have access to the mass, which is 1.5. Now the final speed is given by 0.18. Now here you can place the minus sign, no worries, because we have to the power of 2 minus half 1.5, and that would be minus, so or no 0 point, because the initial speed was already positive. And plugging that expression on the calculator, we're gonna have a value of minus 0 point. So here you can either represent your answer to be negative or positive, that's fine. So let me say, but if we're talking about the energy loss, we should say the value of this energy. The minus sign itself, it indicates that we have lost energy, but what's the value of this energy loss is given by 0.012 joules. Then the energy loss is 0.012 joules. And that's it for me in this video, guys. See you soon in a new one.